Let's identify types of functions derived from repetitive adding versus repetitive multiplying. Okay, let's look at some examples. So first, let's consider the two number sequences. We've got sequence A, 4, 7, 10, 13, 16, and we have sequence B, 4, 12, 36, 108. So our first question here, what do we notice about these? Well, in A, 4 to 7, 7 to 10, 10 to 13, 13 to 16, each time we jump numbers, we add 3. So we have a constant change of 3. Of plus 3. In letter B, if we think about adding, well, we would be adding 8, then adding 24, then 72. Those are not a constant add, right? A constant change. But from 4 to 12, that's multiplying by 3. 12 to 36, that's multiplying by 3. And 36 to 108, that's multiplying by 3. So we would say this is a proportional change. Some also call this equivalent ratios, because if you work from one number in the sequence to the previous, if we take 108 over 36, we get 3. If we take 36 over 12, we get 3. So if you look at consecutive numbers as a ratio, we would get that. That's where the whole proportional idea. So the proportional change of, I'm not sure what, why did I put an equal sign there? Okay, so this is like times 3. So we have two different types of pattern. One with a constant change, think add or subtract, and the other with a proportional change, think multiply or divide. All right, let's take that and let's move on. So we are going to talk about the difference with a linear function or an exponential function. With a linear function, we have the constant rate of change, meaning we are dealing with adding or subtracting, but it has to be constant. We have to either be adding by the same value every time or subtracting by the same value. Now with exponential functions, we have a proportional rate of change. So we're thinking with multiplying or dividing. So you're either multiplying by the same amount or dividing by the same amount. The reason each of these has 2 is because adding and subtracting is basically the same, and multiplying and dividing, again, basically the same. So let's look at these. Identify the following situations as linear, exponential, or neither. Now, in letter A, we're given a set of ordered pairs. So first off, how do we talk about this? Well, the 1 just tells us this is our first number. This is our second number. Here's our third, and here's our fourth. So we are really looking at the pattern of 4, 3, 2, 1, right? The second numbers. Well, if you notice, I subtract 1 every time. So this would be linear because we have a constant change of -1. That's the same as adding a -1, right? That's the idea of subtracting. So the first one is linear. Now let's look at the second one. We have just a list of numbers, like a set, like we started with. 200, 150, 25. Well, we're dividing each of these by 2, and remember that dividing by 2 is the same as multiplying by the reciprocal or multiplying by 1/2. So this is exponential with a proportional change of 1/2. You also could say dividing by 2. Mathematically, those are equivalent. Letter C, again, first number, lost my pen, first number, second, third, fourth. So let's look at the numbers, 6, 12, 24, 48, right? Just looking at the Y values of these ordered pairs. 6 to 12, 12 to 24, what's happening? Well, each time it doubles is the same as multiplying by 2. So again, this is exponential because we have a constant proportional change of times 2. Okay, let's look at letter D. We have a set of numbers, 6, 12, 14, 20, 22, 28. Okay, so this first one, we're either adding 6 or multiplying by 2. Okay, then we either add 2 or multiply, no? And then we add 6, and then we add 2, and then we add 6. Okay, so we're definitely not multiplying. But if we look at the adding, we add 6, then we add 2, then we add 6, then we add 2. This is neither. Because to be linear, it has to be constant adding the same number. Not like add some others. No, a constant add. Letter E. We have 2.5, 3.7. We have decimals. But from here to here, I add 1.2. 3.7 to 4.9, I add 1.2. 4.9 to 6.1, I add 1.2. So really, the idea is, this one's linear because we have a plus 1.2 constant change. You want to look at consecutive terms. And if you can find a pattern that is a consistent adding or subtracting, it's linear. If it's adding or if it's multiplying and dividing, it's exponential. And that is looking at the repetition of adding versus multiplying to identify your functions.